Welcome to today's tutorial. We'll be going through the overloading the double indexing operator, which is this one. It's a bit more complicated than the other operators, right? So there's a lot that goes into place. So, okay, let me just delete this and then, so remember that, the thing is, how am I gonna explain this? So the thing is, when you're overloading the double indexing operator, like, if you want to overload the double indexing operator, it's not possible. You can only overload a single indexing operator at a time. That's how it works. So since that's how it works, how can we achieve double indexing? It's simple. You create a class called UJRow, which overloads a single indexing operator, and you have another class that overloads another single indexing operator. So let's say this is UJRow, right? And private member variables would be the array, right? So let's say it's like we create a class that represents a specific dimension, one dimension or one one dimension, right? So this will represent my array of rows, right? And then I'm going to overload that operator here, and I'm going to say operator. Single indexing, remember it requires you to pass one parameter. So what parameter should be passed here? It's that row, to get that single row. So this will be an array of, yeah, let me see. Yeah, so this will be an array of rows, right? Because remember, a 2D array is simply an array of rows where each row points to an array of columns, where each row points to an array of columns. That's pretty much a two-dimensional array. So that means I can create one class that represents one dimension and then use the other class to point to that dimension. So therefore, I'm going to have UJRow as the class, which represents my row. And then I'm going to have UJImage, which is going to represent the two-dimensional array, right? It's going to represent the two-dimensional array. So public and then private, like this. So remember, by default, the two-dimensional array of pixels is of type RGB color, whereby we have two pointers representing the two dimension, right? That is two-dimensional. And since we cannot overload double indexing like this at once, we can only do single indexing. That means here I'll take in, for example, a column. Okay, I'll take in a column there. That's why I'll take the column. But then if you look at this one, okay, we are not actually pointing to an array of integers. It's actually an array of RGB pixels. So it's going to be like this. RGB color. Let me just save it because I keep pressing here. So nodes.txt. There we go. And then let me do this. Let me install GIMP because I keep switching operating systems. So let me install GIMP, and then I'm going to set the language to C++ so that it colors the nodes that I'm making here. So as you can see, UJRow represents RGB color pointer. So that means in the place of RGB color pointer, we're going to put UJRow. Then we point to that UJRow, of which the UJRow points to an RGB color. So we're gonna do it in that way. So install for all users. So we're gonna do it in that way. That's how we achieve double indexing. So now the question is, what do we return when we index? It depends on the array. For UJ row, our array is RGB color. So I'm going to return RGB color as my return because the array, this is an array of RGB colors. When I'm indexing, I get back one thing within that array, which is in this case an RGB color. If you return it like this, you're returning it by value. It means that you can only access if it's in that syntax. You can only access. If you want to modify to do both access and update or access and modify, you have to return it by reference. So you can only access. So you have to return it by reference. That's the only difference between the two. The first one returns by reference because I want to access, but then I also want to update because anytime you have an address of a variable, you're actually going to where it resides in memory, meaning that you can change its content permanently, meaning that you can update it basically. So now when you look at this one over here, it's supposed to return a UJ row because our array is an array of UJ rows. That means that each index it's a UJ row. And then obviously I want to be able to modify, I want to access and modify the UJ row. So I'm going to return the UJ row by reference. So this is pretty much what we are going to do in today's tutorial. So we're going to make that array, a class called UJ row to present our row. So now I'm going to open code blocks. I hope this session won't be long. Let's see. Okay, it's already 7 minutes, but I think it should be short because I was testing it out and then I figured out how to fix those issues that I was having. So I'm gonna click next, and then I'm gonna call it overload double indexing operator. Then in C++, but then I'll just leave it like this because I definitely know that it's in C++. There's no need for me to write that it's in C++. So there's our project. So let me create these files as quickly as possible because we have quite a lot of files to create or quite a lot of code to write. So ujimage.h and then save and then remove the underscore included. You don't have to, it's just a preference. So let me just see if I'm recording just to be sure. Okay, I am recording. So we have our UJ image header file. Now we're going to create the UJ image source file. So this will be our source file C++, and then UJ image.cpp. And then I save it inside my folder and then finish. And then I'm going to go here and say new file, header file, next, and then UJ row.h for header file, and then underscore included, and then finish, and then ujrow.cpp, the source file. You see, there's quite a lot to create here. So ujrow.cpp. So this class will represent our UJ row. And then remember at each index, the rows are of size. Remember what I talked about. It's a 2D array, it's basically an array of rows. So let's say you have an array of rows. So imagine each line is the row, right? So this will be row 0, this line will be row 1, this line will be row 2. At each index, it's actually a size of columns, a row or an array of columns. That's basically a two-dimensional array. So this would be an array of 3 columns. Basically can index by starting at index 0 to index 2. So this would be a array of columns. And then at each index of the array of rows, it points to an array of columns. So keep that in mind. So here I'm going to need to include uj row.h. And remember, we have composition. If you look at it here, we have compo. position. And since I'm gonna face potential errors, right, what I can do is the RGB color, I can actually create its own header file. So RGB color.h, because there's potential errors where you don't want secular dependency issues. So I'm gonna create that struct or the record structure here, and then I'm gonna say struct RGB color. And then I'm going to use short because with short, you use less memory. So short red, short green, RG, B, last one being blue. So short red, short green, short blue. So that's my RGB color. And then, yeah, so we're going to need to create the classes. So remember what I talked about. And there's something very important that you need to take into account. Since everything in the pixels in the UJ row in the UJ image class and our pixels array at every single index is going to be a UJ row. We're going to need to define a constructor that takes in the size for this array, which is going to be of size columns, right? Remember what we talked about. Is I'll just make it a short, so underscore calls. Why am I saying calls? Because if you look at the structure of a 2D array, at each index, remember UJ row, it means one row. At each index is a collection of columns, calls. So keep that in mind. So class UJ row, and then public, and then UJ row. We're going to need two types of constructors here, right? The parameterless one and the parameterized constructor. It's a must. If you don't put it, you're gonna have issues. I'm gonna use short to save memory. You can use int, that's fine. So this one will take in the number of columns because this class represents one UJ row. At each UJ row, it's a collection of columns or calls. And then I'll also need an assignment operator. Why? Because think about it, and we can't do a shallow copy here. We can't use the copy constructor. This is deeper than that. You need to use a okay, no, it's deeper than intended. So you have to use a deep copy, which is an assignment operator. Why? Because when you have UJ image like this, right, the constructor, and we are implementing, remember, we need to initialize and say underscore pixels is equals to new, but then at each index is what UJ row. So when we say UJ row like this, and then we pass in the size of our array, which is going to be of size rows, what this does behind the scenes, it calls the constructor, which is the default constructor of UJ row. So it calls the default constructor of UJ row. Because when you say new, it's going to look for a constructor. But then as you can see, I didn't provide any parameters, so it's going to use the default constructor. So if it's not defined, it's going to crash. Hence, we need to define it. And then now when we inside the for loop, and then we have to say at every single row is equals to that UJ row, blah, blah, whatever, right? Look at what's gonna happen here. It's an assignment operator, and what do I have on my left-hand side? A UJ row. Because this will get that UJ row, that one UJ row. So that means I have a UJ row and I have an equal sign, meaning that I need to overload the assignment operator. It's a must. Don't use a copy constructor. Overload the assignment operator. So I'm going to overload the assignment operator and it's going to return a UJ row reference. Then operator equals to, and then it takes in a UJ row by reference. And I shouldn't put const here because I want it to actually change the UJ row. I'm changing. So therefore I shouldn't uh, put a const at the end. And then private, remember what we talked about. You're going to have RGB pointer, which is going to represent my, okay, so since this class represents UJ row, this one over here, this array will actually represent the columns. Hence, I'm passing in the columns. So this will represent my array for my columns, or I'm going to call it array calls. And then this will, obviously, I need to store the columns, so short underscore calls like that. And then the destructor, we need a destructor for this because we're going to allocate this memory over here on the heap. So we need to deallocate it. So therefore, this destructor is important. And since I have a default constructor, I'm going to need a, a variable to represent my default columns if they're not provided, if this is used and the columns are not provided. So let's say it's going to be zero, let's just say 0 columns because this class is just, when I'm not gonna, there's no way I'm going to use, really make use of that. There's no way, there's no way I'm going to make use of this by this default constructor. So I can just say it's a 0. And then obviously you're going to need some default color. So const expression, you don't have to put the default color part, it's not really important, but then we can just create it. Call it default pixel. The default pixel, if it's not provided, let's make it white. If it's not provided, then make it white. That means it's the maximum for each color component. But then since I'm making use, I forgot to put in the type here. It needs to be RGB color. And since this RGB color has multiple values, I need to use const expression. When you use const, you only use it to I forgot to put the type again here. Hey, me and my mistakes. So when you use const, it means that it's for, we have one value this side, or it represents, you're trying to initialize one value or or an integer basically. And then if you have multiple values, more than one value, or it's not an int, then use a const expression. As you can see, these are 3 values. It's more than one, so I need to use const expression. I don't use it, I'm gonna get an error. And then hash include RGB color header file because I'm using the RGB color here. And then I'm done. That's all you need to define within this class. And all of this that I've defined, they are very important. And then I come here and then I say uj row, and then I do this, and then now I'm implementing, right? So there's quite a lot involved just to index, which is really annoying. That's why there is the proper way of indexing. This is just if you want to really treat it like an array, this object. So you have to overload this double indexing operator this way. So once I'm done here, I'm gonna need to delete my array of columns, right? Array calls, but then it's going to be allocated memory for that. So because it's going to be of some size, right? So I'm gonna delete that whole size. And then once I'm done, I set it to null pointer. So that if I try to access this deleted memory, it gives me a segmentation fault error. And then I'm going to chain to my constructor. Remember, constructor chaining, what it does, it simply copies the code that will be here, all of it. And then where it sees this parameter that's being passed, replace it with the one that I'm gonna pass here, which is going to be default calls. And then I come here, I'm gonna initialize my columns is equals to this columns that I'm getting from the user. And then my array calls is equals to new RGB color. You see, it's going to be allocated on the heap. So therefore, we need to manage that memory. It's RGB pointer. So that means at that, I need to replace the pointer with the square brackets so that I can provide the size for that dimension. The sizes of size columns or calls. And then I can initialize the pixels right now. Now I can initialize the pixels. So short C is equals to 0. C is less than underscore calls C++. And then underscore array calls at that specific column C is equals to, remember this is going to be return an RGB color. So therefore I need to use curly braces to initialize that. So if it's not provided, set it to 255, 255. So we actually didn't need the default pixels. Yeah, this constant here, we didn't need it. Yeah, let's just remove it. We're not gonna use it. So I've deleted that, and then there's my implementation. Everything is done. Then we do the copy constructor. But then I know at the end of the day, and remember when in C++, it's allowed to omit the names for the parameters in the header file. Why? Because I'm not going to use the access the values of those parameters. So I can just pass the type and then that's it, and it's going to work. I also only pass the type here and it's going to compile very well with no issues. Then I'm going to go this side. Now, if I want to reference that value that's being passed, I need to give that variable a name. So obj row, that's what I'm going to call it. Or no, obj right-hand side, because what's being passed inside this function will be on the right-hand side of this equal sign. Once I'm done, I'm going to return my object. Remember, this operator returns the address of this current instance. But then I don't want the address, I want the object. So that when the object is returned, it gets the address of the object. So there's that. And then I'm going to do an if statement. If this keyword, meaning this current instance's address is not equals to the address of that object that I'm trying to copy from. Basically, it means that the objects are not the same. If these objects are not the same, or they don't have the same, remember they're the same if they're at the same address, meaning that they're going to have the same values. So if they're not the same, then you can do the assignment, you can copy. Remember the order of us doing the assignment, right? You start by deleting to make sure that there's no junk inside that array. So I'm going to delete that array. As you can see, I'm going to repeat this. So that's why you need to create a helper method to just put it in a helper method and stop repeating yourself. And after deleting, you allocate, and then after allocating, you copy. So you see that it becomes a very repetitive process, especially if you have a copy constructor too. So it becomes very repetitive. So since we're gonna repeat ourselves, I'm gonna make it private, meaning that's going to be only known by me. If it's only known by me and it's a function, we call that a helper function because it's simply meant to help you write less code. So I'm gonna call it de deallocate deallocate, which is meant to change, right? Delete. So I shouldn't put a const at the end. And then I'm gonna have a void function called allocate memory, which is meant to allocate memory. Basically, it's going to mimic a constructor. So that constructor only takes in one value, which would be the number of columns. And it's meant to change, so I shouldn't put a const there, right? And then to copy, so let's just create the copy constructor. I don't see the need, but then let's create it because we have an assignment operator. But then let's create it. So const uj row reference. Remember, the copy constructor is the same as the assignment operator, even the parameter. That's why you see the parameters are the same because it's the same thing. But then the only difference is that this one performs the shallow copy, meaning that we don't make sure that the objects are the same size. It just copies and then it ends wherever it ends. And then this one performs a deep copy because we start by deleting the memory and then allocate to make sure that memory matches with the object we're trying to copy from. And then once we've made sure the memory is the same, then we transfer the information. So basically, it's like you have a 2 liter of Coke. Before you pour the 2 liter of Coke, imagine you want to pour all of it out. You'd obviously make sure that the container that you're about to go get is the same size. It's also 2 liters. Then after you've made sure that it's the same size, you transfer. You pour the Coke from this 2 liter, from one 2 liter container to another 2 liter container. And then, so now I need to create a copy construct or copy values, right? Which is going to be mimicking a copy constructor. So uj row by reference, there we go. And then we have these methods. So it's quite a lot. UJ-Row is quite a big class. In terms of that, there's quite a lot of methods involved. And then you see that now I won't need to repeat myself. Whenever I deallocate, I call the deallocate function. Whenever I allocate memory, I call the allocate memory function. So this is part of UJ-Row, colon, colon. And then this to deallocate. How do you deallocate? You say delete that memory for my array of my columns, and then don't forget to set it to null pointer. And then I need to also say this is part of UJ-Row's class. And then now I need to reference that parameter that's being passed. So I'm gonna give it a name, sort of like declaring a variable. So this will be the number of calls. And then that means underscore calls is equals to those columns from there. And then I allocate memory for my array. Since I now have the columns, it's equals to new. And it's an RGB color pointer, right? But then I replace the pointer with square brackets because I want to give that pointer or that dimension a size, which is going to be of size underscore calls. And then now I go through each pixel, short c is less than underscore calls, c plus plus. So all those pixels, I need to set them to a default pixel. So let's say the default, and since array calls, like I said, it returns an RGB color, which is multiple values. I'm going to use a list initializer, which is this curly braces, to say that I'm initializing multiple values. So I'm going to initialize it to 255, 255, 255, which is a white image, right? I'm initializing to a white image so that when we make changes, and we use the double indexing, we can see the image that it did change. We can zoom into the image and see whether that section did change. So this will be obj, I'll call it obj original here, right? Because that's the original object that I'm taking in. And then I'm going to copy. Remember, this just does a shallow copy. I just copy. I don't really check if they're of the same size. So short C, I have to go through all of the columns. And then my obj is original, or I can just call my classes original. It doesn't really matter. So let me call my classes rows, right? So underscore rows, calls, I mean, calls, C++, and then underscore array columns at that specific index is equals to my objects originals pixels or arrays. It's arrays value. So we've copied. And then that's pretty much all you have to do here. Copied, done. So we have our methods. So now instead of me repeating myself, so now this comment needs to go here. That'll give you a segmentation fault where you try to use it. That's why we set it to null pointer. So I just call the method deallocate, which will just go into this function, copy all the code that's there, and then paste it at that specific place where that method was called. That's pretty much what it does. And then here, inside of my constructor, I just call allocate memory function. Allocate memory, which takes in these calls that I'm getting from this constructor. And then now I don't have to repeat the code. All I simply do, I just call the method. So we start by deleting, which is deallocate. And then we go to allocate to make sure that the containers are the same. So make sure containers are of the same size, which is like the 2-liter Coke. So now I'm making sure the container that I'm taking that I have is 2 liters big. And then I'm going to call allocate memory function, which takes in the columns. But then which columns am I taking? The columns for the object that I'm trying to copy from. So underscore calls, there we go. Then once I know they're of the same size, then now I can copy the values. Hence I called it copy values. So copy values. What am I taking in? A UJ-Row, which is this object, which is obj, right-hand side. And then that's pretty much all you have to do. Then you're done. Yeah, we are almost done. Let me see. Yeah, we're almost done. we need to now overload that operator, right? The single indexing operator. Remember our array, at each index, our arrays of RGB color type. So I'm going to say RGB color, return by reference if you want to change. If you don't return by reference, it won't update the pixels. Keep that in mind. So therefore, I'm going to leave it by value for now to show you that it's not going to work. The code will run, but then it's not going to update. So this will take in a column, right? Because this is our columns array. It's going to take in some column, and then that will return a RGB color, and then do this, and it's part of the class. So I need to say uj row colon, and then I need to say return underscore array calls at that specific column. This is my array for all my columns, and I'm indexing to get a specific column. Remember, this uj row points to an array of columns. That's how you represent a two-dimensional array. It's whereby you have an array of rows, and then at each row you have an array of columns. Remember, the class represents each row, so therefore it's going to have an array of columns. I hope I'm making sense. So hash include uj image. So now we're going to uj image. And then now uj image. So uj image, right? We're going to create constructors, right? So I'm going to have I'm going to have a parameterized constructor which takes in the rows and short, which is the columns, and then I'm going to have a destructor, and then private, and then we're going to have remember we usually have a two-dimensional array of RGB color pointer representing all of our pixels. But then an RGB color pointer is already represented by the class named uj row. So this part that I've highlighted is actually now represented by uj row. And then we need to also create our variables to store these rows that we're getting from the user. And then underscore rows underscore calls. So if variables are of the same type, you can declare them in one line separated by a comma. They are all of the same type, short or short int. And then here, am I going to need an assignment for this? Nope. Yeah, I'm not going to need an assignment operator here. Why? Because each pixel uh is maintained by the uj row class. So, and it has the assignment operator, so we are sorted. We don't have to worry about that. Then now I need to overload my my single indexing operator, and then this one will take in the row. Hence, it returns uj row. This is an array of rows. It takes in a row to return a uj row. Then the uj row returns a specific column. And then this is all we have to do, right? And then we're just going to create default rows for this default constructor. So static const int default rows is equals to 10 by 10, right? 10 rows and 10 columns. Just is default, right? For me, this is just a testing, right? I'm not actually making for an actual image. Or we could just make it big. Let's say 50 by 50. So it should be big enough though, at least big enough. And since I want to display uj image is pixel, I need to override the stream insertion operator. Remember, all friend functions or functions that are non-members, they are declared at the top before you declare anything. So they're part of the IOStream library. So I need to make use of the IOStream library. So this function should return as an object of type OStream. And I didn't say using standard namespace, so therefore I need to fully qualify it or write it in full. And then I'm overloading that operator, stream insertion, which takes in two things. On the left-hand side, it takes in an OStream object, And then remember, if you're in the header file, you don't need to give the parameters names. You don't have to. And then it's going to take a const uj image by reference. And then we are done. That's pretty much everything we need here. Then I'm gonna copy this, and then now it's time to implement my uj image. So there's the stream insertion operator there. And then I'm going to create the variable. I'll call it OLHS, which means an O stream, O for O stream, L for left, H for hand, S for side. O stream left hand side. That means this will be on the left hand side of my operator when this operator is used, which is true because when you say C out, remember when you say C out is of type O stream and it's on the left hand side of which operator? This stream insertion operator. And then on the right hand side, you'd have something of type uj image. That's why I'm passing it here. So that when this operator is used, it's used in that way. So I need to go through all of the pixels. Okay, so let me just fix the ones at the bottom. uj image colon or scope resolution operator. Remember, I don't put the scope resolution operator here because this is a non-member function. It's not part of the class. It's not a member. Remember, anything that's part of the class, we call that a member. And friend functions are called non-members because they are not a member of that class. They just act like as like a friend, right? Hence friend function. But then they still have access to private things, right? Which is true because a friend has access to all your things that you keep private to yourself, which is like your secrets and things like that. So short r is equals to 0, r is less than obj right hand side dot get. Remember, it has access to private things, even though it's red here saying that it's private, meaning that you shouldn't select it. But this function is a friend function. That means it can access private members. So dot rows r plus plus, and then for short c is equals to 0, c is less than obj right hand side dot underscore calls C++, and then O left hand side. Remember, UJ image at each index it's pixels, right? So this will be OBJ right hand side dot. We get the pixels array, and then we index twice to get the specific pixel. And remember, this returns the specific pixels, right? And okay, technically you can avoid this, right? Technically, there's since why am I saying so? You've already overloaded it here. That means you can double index. So that means I can technically do this, leave it like this, and just double index straight. What will this do? Remember, when you index the first time, this returns a UJ row. And then when it sees the second index, it's going to get the column for that from that UJ row that you've indexed into. So now I can just use it in that way and then put a space there. But then remember this is a RGB color. This will just once I'm done doing this, remember when you index the second time, you are calling that operator within UJ row, which is this one over here. And what does UJ row return? An RGB color. So I need to say dot red, so dot red, so dot red, dot green, and dot blue. So since I don't want to repeat myself doing this, I'm going to store it inside a temporary variable or a local variable. And I'm going to call it rec color is equals to this. This returns a rec color. Then I'm going to say rec color dot red, as you can see, and then rec color dot blue, no, dot green. It needs to be within that order. RGB, red, green, blue, RGB, red, green, blue. It needs to be in that order. If it's not in that order, your pixels won't be, your image won't display well. And then I'm going to send into this output stream an end of line character so that it shows the pixel in grid form. So once I'm done with this column, with the last column, it's going to output an end of line character, meaning the next row will be displayed in the next in the next line, hence forming a grid. And then this function expects me to return a OStream object. So I need to return the OStream object. And then it's going to get the address. So you don't have to worry about that. And then the constructor, right? Remember constructor chaining. I'm going to chain this to my constructor that takes in all the parameters, and I provide the default rows and default columns. And then I'm going to need a default pixel because I don't have a default pixel here. So I'm going to create a variable for it. So for default pixel, right, it's of type RGB color, right? Or you can call it default color. Let's say default color to make things simple. And RGB color is a struct or record structure. So therefore, you need to provide three values. So hence, I'm going to put curly braces. So that means I'm providing more than one value. So I cannot use const anymore. Const is applied when you have one value on the right hand side. You see, I only have a 50. If you even if you ever had a double, you can even if it's like this 50.0, it's still one value, which is 50, but then it's not one thing. You have a dot, then you have another value, which is a zero. So you have multiple things. So with a double, you'd have to make it a const expression because you have more than one thing. Same applies with RGB color. You have more than one thing, so you have to make it a const expression, or else you face issues. So the default color here will be 255. 255. I'll make it 255 white, a white image, right? And then now we can initialize our image. So underscore rows is equal to rows, underscore calls is equals to calls, and then underscore pixels. This is the tricky part. Underscore pixels is equals to new UJ row, right? Because at each pixel it's a UJ row. And then I provide, remember it's a UJ row pointer, meaning it's an address to a UJ row. So I'm going to say, I need to remember when you allocate, you need to replace that pointer with this with square brackets to provide the size for that dimension. So I'm going to provide the size here, which is of number of rows, because UJ row stores the number of rows. And then now I go through each row. R is less than underscore rows, R plus plus. And then at each row, I'm going to need to initialize the pixel, set the pixels at that specific row. So what I can do, right? Remember at each row within this pixels array, each row is actually a UJ row, right? So what I'm going to do is I'm going to create what I call a temporary UJ row object by calling its constructor, right? This will force the assignment operator to be called. Why? Because I'm going to have an assignment here, and then on the left hand, and think about it, an assignment operator will be invoked here, because on the left hand side I have a UJ row, and then on the right hand side of the assignment I have another UJ row. Isn't this familiar? If you go back to UJ row, look at the assignment operator, it takes in a UJ row, and we are working with another UJ row. Remember, this keyword refers to a UJ row. So therefore, in that line of code, the assignment operator will be called. That's why we needed the assignment operator. But then I don't want to call the default constructor. I want to call the parameterized constructor so that I initialize my array in that side. Remember, we also need to allocate the columns. So I need to pass the size so that the columns will be initialized, right? So that the columns initialized to that value, the number of calls that I got from the user. So this creates a temporary UJ row. Since at every single row, it represents a UJ row. Once we have that done, we are done doing that, right? Then we can actually leave it. Yeah, this is fine. Why is it fine? You need to really understand why is it fine? Because inside UJ row, we initialize the color. There's the color. That's where it's initialized. Remember, UJ image only manages the UJ row, and then the UJ row manages the columns. So it's managed on the other side. I can leave it here. I'm done. Since because it's going to be managed on the other side. And then I go down here to my distractor. Now we delete. So delete that memory allocated for the pixels. And then after deleting, what I'm going to do, I need to set pixels to null pointer. And then we'll be done there. And then now to return here, it's simple. It might not look like it, but then it's simple. You just say underscore pixels, and then you return the row. So this will return the UJ row, of which the UJ row will return a RGB color. So that's how it's going to work. So this is pretty much all you have to write here. Let's see if we don't have any errors. Okay, we have an error here. Okay, UJ row is not defined, I know. It's going because I didn't do the forward declaration. Does not name a type, yeah. So you need to do a forward declaration to say UJ row, which basically creates an empty class. So that's a forward declaration. So even if we do forward declaration, we still need to include the header file once we call the methods. Pay attention to what I'm saying. Once we call the methods within the class, we need to provide the header file. That's why inside this header file for UJ image, I didn't say include ujrow.h because I'm not calling the methods within the class. But in my ujimage.cpp, I need to call it that header file because I need to include the header file because I call methods. You see, it's gonna crash and say that method is not defined, blah blah blah. Or RGB color. Let me go back here. So the issue is complaining is that RGB color header file is not included. So let me include it here. It doesn't know what RGB color is basically. Does not name it. When it says does not name a type, it means that it doesn't know. It couldn't figure it out what that thing is. So that means the header file is missing. So you see, passing const, blah, blah, blah. Okay, this is not, yeah, I'm going to show you what the real issue here. Don't do this, right? Don't do that. Because remember what we said, this is going to invoke the assignment operator, but the assignment operator actually returns a UJ row. Even though okay, this should be working. But then the issue is the assignment operator. Yeah. RGB color, yeah, it's a weird thing. Yeah, don't do that. So let's do it this way. Let's just do it directly. Let's not do that. Let's just cut and then I'm going to just do this. Because it seems like if you do that, it gets confused. So let me declare it that way. But then it should complain that it doesn't know, okay, is this blah blah blah. Okay, which is fine. I'll do this, right? Is this? Okay, it's fine. My code is fine. Yeah, my code is fine. Remember, okay, before we continue, we're inside the header file and we're gonna call methods from the UJ row, right? Hence, you see here I'm calling a constructor. If I don't include the header file, it's going to say it's incomplete, it's an incomplete class. You see, it's going to say incomplete type. Oh yeah, that's one of the other reasons it's complaining. Incomplete. Basically, it doesn't know that there's a single indexing operator since we haven't included the implementation. Therefore, I need to include the header file here so that when I call any method or anything within the class, it knows what I'm talking about. But then we're still gonna have an issue because why? You need to really understand this. Remember, when I index the first time, it's gonna return a UJ row, right? This part that I've highlighted is gonna return one UJ row. So it's gonna return a UJ row which is basically an address. So you need to actually dereference to point to that object like this. So you need to, because this will return that UJ row. Remember, UJ row has been declared as a pointer here. You see here, UJ row has been declared as a pointer. So that means if I want to get the actual UJ row, I need to dereference. Let me see, this should work. Let's see. Okay, still doesn't want to work. But then this should have worked. Dereferencing like that, and then it gets. So it seems like it doesn't want to work. Let's just call the array directly. Let's not use that operator. So let's say underscore pixels RC. Yeah, let's just use the array directly. Let's not complicate our code. And then it's going to complain here. Why is it complaining? Undefined reference to da, 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 da. Okay, let me do this. Let me remove the copy constructor here. I'm not sure why it's complaining about undefined, or maybe that invokes. Let me see. Where's the copy constructor here? Oh, I think, oh, I think that's why I hadn't implemented the UJ row. So let me go back here and let's implement the copy constructor. I mean, I hadn't implemented the copy constructor. So I'm gonna go here, copy, and then I'm going to call the copy values function, which has the code for copy constructor, but then I need to reference that object, so I need to give it a name. So object original. And then let's see if now the error goes, yeah. So I had forgotten to implement the copy constructor. So now we're actually done. It's surprising, but then we're actually done. So let's implement it, right? Let's try to use it. So what I'll do is I'll output the image before and after. So I'll output text, right? So hash include uj image.h, and then I'm going to create a uj image. So uj image, obj image, and then I'm going to output before, and then end line, and then I output the object. So remember the object is, the operator has been overloaded. I don't need to call it to ppm function. I just use it like this. And then once I'm done outputting before, then I output after, meaning after the changes I've made, after I've changed a specific value. So see out obj image again, end line. And then so far, let's see if everything runs. So far, there's nothing that's going to happen, right? You're just going to see the exact same image. But then this is too big. This is a too big image. I want it to be like 10 by 10. Let me use the parameterized constructor and create a 10 by 10 image so that it's smaller. You see, it's easy to see. So remember, it's a set of three values. Three, meaning that's the first pixel. Three, this is the second pixel. So to see that so that I can be easy, I can easily tell whether it worked or not. I'm going to change here at index 00 to change it to some different pixel using the double indexing now. So remember we said after, so before this comment or even after that comment, after outputting, I can index, I can say obj image at index 00, change it to be that pixel. This will return an RGB pixel, RGB color, right? And to initialize an RGB color, it has multiple values. Hence, I'm going to use curly braces. So change it to 0, 0. So let's see if it's going to work. Okay, for use of incomplete class UJ row. Why does it keep thinking UJ row is incomplete? Um, okay, seems like it wants me to re-include the header file inside main, the UJ row, UJ row header file inside main, because it's saying it's incomplete because it still thinks, I don't know why it doesn't pick it up. So I just have to include it here. Yeah, you see, I had to re-include the header file because it thought it was still incomplete. So clearly something went wrong here. So the only plausible thing that I can think of that went wrong is that we didn't return it by reference. So this is not allowed. It's not allowed. Trying to change it like this is not allowed. So let me go back here and just double check if I've set it up correct. I've deleted correctly. Okay. Delete that memory, set it to null. Or maybe I shouldn't set it to null yet. Let me comment out this line. Yeah, let me not do that yet. Let me see if, but then that shouldn't really be an issue. Yeah, it shouldn't really be an issue. So let's just change those operator functions that we've overloaded to return by reference, right? Meaning that they can modify the value. So I need to go there. Where's the operator? Where's the operator? Yeah, they raise here. RGB color by reference. Also in the header file, in its header file, I need to return RGB color by reference. And then I go back inside ujimage.h. I need to return a UJ row by reference so that I can modify it. And then here UJ row by reference. So let me build and run and see now. Yeah. So you see, it was crashing because you didn't return by reference. So you're trying to modify and you didn't have the privilege or the right to modify. As you can see, it has modified the first pixel at 0, 0. You see, it changed from 3 255s to 3 zeros. So it did modify. So that's pretty much how you overload that double indexing operator. Maybe I will create the videos for the other operators, but then the other operators are pretty straightforward. Let's also overload this one. Let me see if I can do that within the session. Yeah. So let's also overload this one using this approach. You'll see that this approach that we're about to use, it's way better. It's straightforward. You wanted to overload it this way because you wanted to treat the object the way you treat an array. So it's the same thing. UJ, okay, this one is fine. You can just return the RGB color as it is. So you can return an RGB color. You don't need to create a UJ row to handle that. No, you don't need to create that. So you create operator, and then this operator. And then this one is fine because it allows you to take in two parameters. So I can take in a row and a column because I want to access. And it depends whether you want to update to be able to you see, they said you should also update after accessing. It means that we need to return it by address. You see this address of, if it's not returned, and you saw that your code is going to crash if it's not returned. So I'm going to copy this and then implement it. You see that it's still the same thing, very easy to implement. So here it's going to be UJ image, copy, and then exact same code, but then now it doesn't return, it doesn't point to UJ row indirectly, things like that. Straightforward. It returns what is supposed to return, an RGB color. So now let's index. So we're going to say underscore pixels row, uh, which will be row, and then which will be call. And then remember what we're doing here, right? We're actually using this operator. Why? Because we've made our two-dimensional array to be a UJ row, pointer to a UJ row. So if you didn't define this operator here, this one it's not gonna work. So there's this operator, just say return row. What's gonna happen? Remember what we've been talking about. This part that I've highlighted over here will return a UJ row. So let's say OBJ row, it returns a UJ row. And then I use the single indexing operator within the UJ row to get a single RGB color. So that's what it does behind the scenes. That's why I'm saying this needs to be overloaded first before that can be achieved. And since it's going to call this one within the UJ row, so within UJ row, you also need to overload that single indexing operator. So let me build this. They should run perfectly fine, no issues. There we go, done. Then I'm going to say after overloading this one, right? And then I'm going to pretty much do the same thing, right? Pretty much something similar, but then now I'm overloading this one, right? This one is easy. Remember, we don't use it that way. We need to use it this way. I provide a row and a column. So which row do I want to change? Let's also change that first row and first column. So that row, and remember, if you don't return it by address, if you use an assignment, it's going to crash because it means you cannot update it after returning it. So that's why we return by reference. So to make sure that it's actually different values, I'm going to change it to triple ones everywhere. And then I output it again. So we're going to see three outputs: the original object before we made changes, and then there's our object, done. So you see everything's working perfectly fine. So we have the first three, that was the original, and then we changed it to 3 zeros using this double indexing, and then we changed it to triple ones using that approach. So that's pretty much all you have to do, for this practical. And I know some of you are struggling and you should be very happy now. So we could also check the image. Before I close the session, let me check the image. So it's really annoying, but yeah. I have to open this folder within that terminal that I told you guys to download. So I need to copy the path, change the folder. That's why I prefer Linux. Linux, by default, everything can be run by the terminal, so you don't have to stress about that, about downloading different terminals and doing this. Yeah, you just open the terminal and then you start running. So I'm going to right click and click paste. Why isn't it pasting? Right click and paste. Okay, it seems like it didn't copy the path. So Control C, copy. Okay, something is not right here. So Shift, insert, Shift, insert, and then I'm gonna press Control A to move the cursor to the beginning. And then I'm gonna say CD to change. CD means change directory because I want to move into that directory. And then // So since this is going to be tricky, I don't want to output so many images, right? Um, why is it saying too many? Oh, because my folder is named with a space. So do not do that. That's why I always want, if it's named with a space, you need to put the path inside double quotes. So Control A to move my cursor to the beginning, and then there we go. So make sure you don't name your folders with spaces. So there's my file. So what I'm going to do, right, since I want to generate each individual image, I'm going to, and remember to generate the image, you don't output text, things like text is going to affect the output. So that means I need to comment out this, comment out everything from there up until there, so that I only have this output. So this will be what we call our original image. So I'm gonna generate that image now. So G++, compile everything that ends with a .cpp, send the output to a file named main, call it main, and then it's gonna compile. If no issues were found, it's going to compile successfully. So let's wait here. No issues were found. ls, there should be a main.exe. There it is. And then now to execute it, I say /main.exe greater than to redirect that output to a file. And I'm going to call the image original.ppm. Then done. So I should have an original image. So now I go back to my code, I make changes. I comment out this original line, and then I uncomment the lines whereby I overloaded using this, right? Which will be these lines, which will be these lines here, right? So I need to call it, what is it called? Double indexing. It's called double indexing, right? Yeah. I'm gonna call it square. The image, I'm gonna call it square, and then the other where I overloaded this round one, I'm gonna call the image round, so that I can tell the difference. That's why I'm coming up with those images, with those image names. So I need to recompile again because now I've made changes to my main.cpp. I recompile, it runs perfectly, and then I re-execute, but then the image I need to now call it square, because this is me overloading that double indexing through the square syntax, the square operator, that operator. Done, right? And then I go back to my code, and then I comment out these lines, and then I only uncomment the lines where I was using that different one, so that you see that the pixels did change. So now this one is called round. The image, I should call it round. And then I compile again. Oh, okay, so there's a comment here, my bad. And then save and then compile again. And then I'm gonna call this one, what am I gonna call it? Round, yeah. So I'm gonna call it round. And then now we can open the different images. So I'm gonna go back here. I have the original image, which is just the white background, right? It's just a white image, white background. So I'm double clicking. Seems like it's taking its time to load. Yeah, it's taking its time to load. So let's just be patient. Let's wait. Yeah, I don't know why my laptop is lagging when it comes to opening GIMP. Uh, Come on. Okay, let's just wait. But then that's pretty much all you have to do. Just that the first one, whereby you're using that's the square notation, you have to create a separate UJ row, and then you have to overload an assignment operator within the UJ row, which is a bit of like the long way of going about it. So let's just wait for it. Wait, wait, wait. This is why I like Linux. It would have opened a long time ago. Image could not open. How come it's not able to? Oh, okay, I see. My bad. It's my bad. I'm sorry for that. I forgot. Damn. So I need to restart this process. So I forgot that the PP image you need to output P3 first, the columns and the space and the 255 maximum intensity. Yeah, I totally forgot about that. So I'm gonna go back here. Where's the function for printing? Yeah. So here I need to say all left-hand side. So it couldn't interpret it as a P3 image because I didn't follow the rules. So this would be an end line. So that the next text starts on a new line. And then I output the columns here, which is inside the obj right-hand side. So obj right-hand side dot underscore columns and then space and then followed by the rows dot underscore rows and then you move to the next line. But then I didn't say using standard namespace. So before I forget, I need to say std colon colon L and then standard namespace colon colon because I didn't say using standard namespace. And then here I'm going to output the maximum intensity, which is 255, and then standard namespace colon colon and line. There we go. So this was the only thing that was missing. So yeah, make sure you follow the rules. So it's fine. I'm gonna start, since this code is already uncommented, I'm gonna start generating the round image, right? So I'm gonna go back up. You just press the up arrow to rerun the thing to see the commands that you ran. So this is the round image. So round, that's fine. And then I'm gonna comment out this code. And then I uncomment the part for changing using the square, which is this part here. Then save the changes and then compile. And then create an image called square ppm, and then last but not least we need the original image, which was just a white image. So this is just here, I just display the image and I'm gonna call it original because that's the original image. So original, there we go. So we have all three images. So yeah, at least now you guys can submit your practicals and get total. So I'm going to come here and then open the files. So I'm going to start with original. Okay, so you see that it will just be a white image, right? Just white. You see, it's a white image. It's very small, right? It's very small. You have to zoom in. And then the round image, that's when we use the round notation. I don't know if I did change it to a color or I did give it a color. Yeah. So you see, there's the round image. You see, it did change the image. And then I'm gonna go back here and then to the square. We should see another color, which is black. Yeah. So you see, there's that corner because I said go to row 0, column 0 to change there. So as you can see, even in the images, the evidence is there that we did change the images. So that's pretty much all you have to do for this practical, for this indexing for the indexing part. So all the best with your practical.